Good day, everybody. Once again, we are back together, just looking at, still looking at calculus. We're going to be talking about differentiation rules today, and of course, just applying that. So if you haven't subscribed, please just make sure that you're part of the family. If you're new to this channel, welcome, welcome, welcome. Hope you'll be here to stay and be part of our family. And of course, you can hit that notification bell just to make sure that you are notified every time that we are posting a new lesson. And of course, if you need assistance at any given point with mathematics or physical science, you're more than welcome to just get in touch with us. Our email address is info@mlungisinkosi.co.za. All right, let's get right into our lesson. And we're looking at differentiation today. We're just quickly going to look at the rules of differentiation. And what I want us to start with is just to quickly talk about, just finding the derivative. So in this case, the first rule is that if we've got f of x as a constant, okay, so if our constant is k, then we know that when we take the derivative of x, all right, this will simply give us 0. So when we take the derivative of a constant, that will always give us 0, okay? And then secondly, what I would like for us to know is that if f of x is equal to x to the power n, right? So the rules of differentiation, okay, if we take the derivative of x, in this case, that will simply be n, right? So in this case, it's that power there, x to the power n minus 1. So you jump down and you subtract 1 from the power. Okay, so that is the second rule, right? We're going to apply all of these rules, by the way. And the third rule is, if we've got f of x being equal to, in this case, if we've got k, x to the power n. Now, in this case, k being a constant, right? So what we are simply going to do is, we know that if we take the derivative, okay, just note in this case, it means that we are going to have k multiplied by n, all right? So it means we still have that constant there, right? Multiplied by n, multiplied by x n minus 1. So in this case, it means that the coefficient, or in this case, the coefficient of k multiplies to the power. In this case, what was the power? And we subtract 1 from the power, okay? And just another thing, so if f of x, or in this case, let me just express it this way. Whenever we take a derivative, now, I want you to please note there are so many other ways, and we're going to talk about the notations. I'm choosing this one. If we take the derivative with respect to x of f of x multiply, or plus rather, g of x, whether we are taking the derivative of the sum of two functions, what we do know is that the derivative of x, if it's f of x plus g of x, will be equal to the derivative, now please note, the derivative of f of x, okay, plus the derivative of g of x. So what are we simply saying, right? The derivative of the sum, okay, will be equal to the sum of the derivatives, okay, right? So in this case, of course, it's the same with subtraction as well. All right, so we are going to look at those. Even if you take the derivative of the difference of two functions, it will be equal to the difference of the derivatives, okay? Right, so this is in the case where we've got probably, two functions that are added together, and as a result we can take obviously the sum of the derivatives. Now let's just apply a few rules, okay, or let me just show you different notations when it comes to derivatives. All right, so the first one, of course, is the one that we are always used to. Whenever we are given f of x, we can express, so if f of x is some function x to the power n, okay, so the first way that we can talk about if the derivative or the notation in this case would be f dash x, right? So f prime x, of course, we always say this is nx to the power n minus 1, right? Right, but another way is if, let's say, we were given that as y is equal to x to the power n. So how we can, another notation, okay, we can talk about dy over dx, okay? So this is the derivative of y with respect to x, okay? And of course, it's still this very same thing, nx to the power n minus 1, right? So this is the alternate notation. And then we also have another notation that we can talk about the derivative with respect to x, okay, of x to the power n, right? Now, we're going to talk about these rules just in a bit in this case. So I want you to please note, the moment where you start taking the derivative, all you simply do is that you are going to remove this expression, because this simply says take the derivative of what's in the bracket, right? But in this case, once you take the derivative, it means you must now remove that dx expression. So that would be equal to nx to the power n minus 1. Okay, right. And I want you to please note, we don't always take the derivative with respect to x only. All right, we can have, you know, especially when it comes to maximizing and minimizing, in calculus. So sometimes we can even have, you know, let's say for argument's sake, you've got t. We give you an expression t squared minus 2t or whatever the case may be, right? So what you can do when you, so this would be f of t. So in this case, you can actually take the derivative with respect to t. And of course, we would just find out how to do that. Okay, now, just a couple of rules that we need to make sure that we familiarize ourselves with, right? Is that when we are going to take the derivative, and in particular, you see, when you are dealing with quite a number of variables and so on. So the first thing that we need to do is that, number one, we're always going to try and remove brackets, okay? So we must remove brackets, okay? So we're going to remove brackets. So let's say for argument's sake, you've got an expression f of x is equal to, let's say, x plus 1 and 2x minus 1. Okay, now what do you do? Of course, before, if they ask us to take the derivative of this function, what we're going to do first is that we're going to get rid of those brackets. Of course, you're going to multiply into them, right, using the FOIL method. So that's 2x squared, and in this case you've got minus x, you've got plus 2x, and you've got minus 1. And of course we try to simplify that. This is going to be 2x squared plus x minus 1. So that's our f of x. Only then can we now apply, in this case, can we take the derivative? So our derivative in this case would be, right, so let's start with the first rule. So we jump down. So that would be 2 times 2. That would be 4x, okay? Applying the third rule there. Plus, in this case, if we take that, that becomes 1, because then you'd have x to the power 0, it would be 1 minus 1. And here we've got the derivative of a constant, and we know the derivative of a constant is 0. So in this case, you'll just have 4x plus 1, right? And then the second thing is, we said you remove brackets, the first thing. The second thing is there shouldn't be, so there's no x in the denominator, right? So in fact, let me just put it there. So there should be no x in the denominator, right? So no x in the denominator. In the case that you've got a fraction, denominator, all right, so you try and remove x in the denominator. Of course, you'll see how we did that when we had when we're doing limits, right? So if I've got something to this effect, if I've got f of x, let's say this is going to be 3x squared minus 2, okay, all over x. And we are supposed to take the derivative. Once again, ladies and gents, if I take f, okay, so first of all, I need to get rid, before I take f prime x, which is the derivative, so I need to simplify this. So it means that I'm going to say, well, this is going to be 3x squared, and this is where the laws of exponents come in, all right, divided by x minus 2 over x, okay? So please note, in this case, we've got, this is x to the power 1, that's x to the power 1. So the laws of exponents, so they'd say, well, if I've got bases, if my bases are the same, okay, and I'm dividing, so we know that this will be x to the power 2 minus 1. Okay, I'm just trying to remind you of the laws of exponents, okay, minus 2. Now this will be x to the power minus 1, of course. When that goes to the top, in this case, it changes sign, right? So now you've got 3x to the power 1 minus 2x minus 1. So what are we going to do here? So this is our f of x, all right? So if we're taking the derivative, we're simply going to say, well, this is going to be 3 minus, actually, that's going to be minus 2 times minus 1, okay? Remember the jump down. So that's minus 2 times minus 1, so that's going to be plus 2x, so that's minus 1 minus 1, that would be minus 2, okay? So that would be our derivative. So the second thing is that you're going to remove x in the denominator. And the last thing, okay, so you should not have a root, okay, or in this case, surds, right? So I'm going to take an example just right now. If I've got f of x, all right, which is equal to 3, let's say, square root x, okay, and I take I'm supposed to find the derivative. How do I do that? So first of all, I'm going to remove the square root, or the root in this case. So how do I do that? So remember, so this would be 3. Now note, the square root, or the root, remember there's a 2 there. And in this case, remember there's to the power 1 over there. So this is the same as taking x, that would be the 1 that we had, over the 2 there, okay? So that's 3x to the power 1 over 2. So what I am simply trying to say is that if we've got the root of m, okay, x to the power n, this would be the same as x to the power n over m, okay? So whatever that root is, the m root of x to the power n, that will be equals to x to the power n over m. So in this case, when we take the derivative, okay, now we can simply say this is going to be 3 multiplied by a half, okay, to the power x 1 over 2 minus 1. So what do you end up with? You end up with 3 over 2 x to the power minus 1 over 2. Okay, so that would be our derivative. Okay, and please remember all of those alternate ways in which we express the derivative. All right, so what I want us to do very quickly is I want us to take a couple of examples that we're going to do together, all right, where we are going to be applying all the different principles. Okay, right, let's take these two examples and see how to navigate around them. All right, so the first one, they said to us we should determine dy dx, okay, the derivative of y with respect to x. So this is when we're given that expression. So we said, first of all, we always need to remove surds. We always need to remove x at the denominator, right? So starting with our, the first one, so we're going to say, well, this is going to be x, right? First of all, remember how we expressed that surd. That's going to be 1 over 2, x to the power 1 over 2, minus, in this case, we've got 1 over 2. If we take the x to the numerator, that becomes x to the power minus 2, okay? So what do we then have in this case? So if we take the derivative, remember we said the derivative of y with respect to x, this would simply be, right, so that's going to be 1 over 2 x to the power 1 over 2 minus 1, okay, minus, so we've got 1 over 2 times, if we take that minus 2, it jumps down, so that's going to be minus 2 to the power x minus 2 minus 1. Okay, so in this case, that's going to simply be 1 over 2 x to the power minus 1 over 2. Okay, of course, that's going to be negative a half times negative 2. That becomes a positive, and 1 over 2 times 2 is a half. I mean, it's 1 rather. So that's going to be x to the power minus 3. All right, so that is what we would have ultimately at the end. Okay, right, and then the second one, they said, okay, we should find the derivative with respect to x of 2x squared minus x minus 15. So let's do that quickly. So the derivative with respect to x, 2x squared minus x minus 15, all of that divided by x minus 3, right? Now remember, in this case, you do not remove the expression for as long as we haven't taken the derivative. So what must we do? We must try and get rid of the x in the denominator, right? So in this case, what are we going to do? So I see that's a quadratic function at the top. So is it possible for us to actually factorize this? Okay, so you always look out for that opportunity to factorize. Okay, so if I look at that, I'm going to have, I would have actually, let's see. So if you use your factorization principles, so we would have 2 over 1. Okay, so in this case, what are the factors of 2? That's 2 over 1. And what are the factors of 5? It's 5 and 3, right? And in this case, if I look at it, if I say, well, factors of 2 and 5 and 15 rather, such that when I multiply them, okay, and take the difference, it will give me 1. And I can see 2 times 6 will give, 2 times 3 will give me 6. 1 times 5 will give me 5. And definitely 6 minus 5 will give me, in this case, it will give me 1. So I see that that would be my first bracket. That would be my second bracket. So that would be x and 3. So that's x minus 3. That would be 2x, in this case, plus 5. Yeah, that would have to be plus 5. okay, and divided by x minus 3. And you can already see what's going to happen here. Okay, so it means that this would cancel with that. Okay, so what do we have? Okay, so what I have is essentially taking the derivative of what? 2x plus 5. Okay, and remember we said taking the derivative of the sum is like taking the sum of the derivatives. So in this case, it means that I'm going to take the derivative of 2x plus the derivative of 5, and the derivative of 2x is 2, okay, and the derivative of 5 is 0. So my answer would be 2 in that case. All right, so that is how the cookie would crumble. All right, what I wanted to just quickly do is also just take an example where we are given, in this case, let's say they give us a derivative of y with respect to t. Okay, I just want to have that in front of me. 3t to the power 4 plus 2 times t squared minus 5t plus 7. All right, so how would we derive that if we take the derivative there? Okay, so this would be dy dt. So you are taking the derivative of y with respect to t. Okay, so again, so this would be 3 times 4 t to the power 4 minus 1. And by the way, once you get faster with this, you don't need to do what I'm doing now. Plus, this would be 2 times 2t 2 to the power minus 1 and minus 5t. Now in this case, remember there's a power 1 there, so it's the same as saying 5 times 1, right? To the power t, 1 minus 1. And in this case, the derivative of a constant is always going to be 0, right? So we are taking the derivative now. So what do we ultimately have? We would have 12t to the power 3, right? Plus 4t minus 5. Because 1 minus 1 would be 0. Anything to the power 0 is 1. And in that case, that's what we have. So in this case, that would be 12t to the power 3 plus 4t minus 5. And that would be our derivative. Okay, right. This case, I just want to take the last example. Okay, and essentially we are going to close this off. So the very last example. Okay, so they say if y is equals to x to the power 6 minus 1 in bracket all squared, prove that dy dx is 12x to the power 5 root y if x is greater than 1. So what we're going to do first is we're going to have to expand that a little bit. Okay, so we have y. Now, of course, if we've got x to the power 6 minus 1 squared, so that we can express it as x to the power 12, right, minus 2 times x to the power 6, okay, plus 1. If you're wondering where I got that from, all I just simply did was to take x to the power 6 minus 1, x to the power 6 minus 1. Of course, once you expand that, you will get this very expression. So that would be x to the power 12, that multiplied by that, x to the power 12. And if you repeat minus x to the power 6 minus x to the 6, you'll have minus 2x to the power 6, and negative 1 times negative 1 will give you positive 1. Okay, so in that case, that's what you actually get. All right, so I just want to remove this. So that's what you have. And so what we want to do now is to take the derivative. So we'd say, well, let's take the derivative of y with respect to x in this case. So again, that's going to be 12. Okay, so jump down, minus 1. So I'm not going to do all of that again. So this would be 12x to the power 11 minus, now 2 times 6 would give us 12 again, x to the power 5, and of course the derivative of a constant is 0. Okay, so if we were to simplify that, we can take out 12x to the power 5 as a common factor, and what we'd have is x to the power 6, okay, minus 1. Okay, so remember that y was equal to x to the power 6 minus 1 all squared. Okay, so that's the reason why they said, well, this would be exactly the same as 12x to the power 5, okay, the square root of y. Okay, because if you think about it, if we take y squared was simply x to the power 6 squared. So this would be the square root of y. In fact, let me not even drag it any further, right? So in this case, we're just simply saying this would be the square root of y. Okay, right. So I want us to leave it there. Of course, we're going to be applying this a little bit further on. All right, but I hope that this lesson has been somewhat helpful. All right, and I'll see you guys again next time. Please don't forget to subscribe. Just make sure that you hit that notification bell, and of course share and like our page, our channel. Just make sure that you tell as many people as you possibly can. Otherwise, from me for now, I'll see you guys next time. Sharp.